Everyone, I want to give you a quick look at using Expanso with Google's brand new Gemma 4 models, particularly at the edge. Gemma, Google just released a brand new Gemma 4 models, and basically they can be thought of as your on-prem open source solutions for state-of-the-art behavior and inference, which is fantastic. But then the question is, what can I use them for, and how do they compare in these low resource scenarios? Today, you have cameras everywhere, which is fantastic, but unfortunately, the intelligence isn't there. Meaning, you can do basic things like obviously ingest and begin to process it, but when it comes to doing more interesting things like identifying figures in those, identifying text in real time, potentially identifying danger scenarios or other things that require significant interpretation, or other objects that you might want to do real time, that's where you're expected to figure out a solution on your own. And more often than not, that solution is move to the cloud and then deal with it when you get there. But that's just not going to work. When you think about the billions of cameras out there in the world where you have real latency concerns and need to cut and restrict it, that's where you need to think about doing more things at the edge, because otherwise your bandwidth will explode, you'll get slow responses, and you'll overwhelm your initial ingestion pipelines. Worse than that, a lot of times you will lose context. If you're just handing individual frames to an endpoint in the cloud, a lot of times that will result in your data being a lot worse off. And that model that you're expecting to turn over great performance oftentimes won't be able to. That's where giving that model important context as you're doing it is incredibly important. So this is where we come to the Expanso demo. Expanso is a platform designed to help you shape what you give to an ML model in line, and ideally do that at the edge. You may have seen me do a lot of these demos where I'll pop over and give you a quick demo of the pipeline. And of course, I'm going to do that here as well. When I go and look at our pipeline, you can see here that this is a pretty complicated one for a bunch of reasons. And I'm going to dive right into the code to show you exactly what's going on. When I pop this open, you can see here, this is all the code of this pipeline. And some of it looks pretty standard. I'm just going to grab my input off the camera that I'm running on. And then my goal is to produce a series of outputs in detections based on what I get from that Gemma model. Now, on the model itself, on the machine itself, I'm capturing the frames right there in line. You can see that there. And then I'm converting them into base 64, which I'm now handling to that Gemma model. And on the machine itself, I'm running llama.cpp and Gemma inside that. And then I'm going to go through a series of different prompts as I execute this. So the first prompt I'm going to give is which of these objects are visible, and I have it restricted to just 4 different objects. You can have it do more, but for the purposes of this, I knew that I would only be looking for a few. And I restrict the number of tokens that I do there so that we can get really fast response. Once I do that, I produce a map, which I then save off to the output. I do the same thing again, but now I'm going to do it by processing all the text from that image. And you can see that prompt there, very straightforward. Again, I'm going to do it one more time where I'm having it describe the scene, 15 words max, keeping it very tight. And then finally, I'll simply say whether or not this scene is safe. And I can respond with either safe or alert, and then I can pass that information too. Once I've done all that, I'm going to do some lightweight cleanup. Again, this is all happening on the edge where I'm reading it, I'm describing it, and passing it through, and then I'll display it in the web page. Now, again, you can hand this off to any other endpoint you'd like, but in under 2 seconds, I'm able to do all this processing. And because I'm doing this at the edge, it means I can take action much more quickly than first having to upload that video to an external endpoint. Further, I'm adding provenance information to this, including the repo that I built this from, the specific location where I executed this model, and other important node information. And this is important for going forward because this is how you're going to be able to recover exactly where you generated this video from. And then when I'm done, I finally output it to the dashboard, which then gets read. And I'll show you what that looks like in just a second. What you see here is our standard web page, which is streaming video in the center section. On the right-hand side, you see three boxes. One, the objects that we are detecting. Two, any text that's being read from the box, from the stream. And three, a description of what's going in. Then at the bottom, you see a notice about whether or not the scene is being identified as safe or not. I'm going to enter in here from the right-hand side. And as you can see, when it sees me, it's able to detect and start an inference. It's looking for these various objects that I mentioned before, and you can see it's identified items that I'm wearing, glasses, what I'm doing, and so on, and then also provide a description. Thankfully, it also identifies me as being safe. Once I leave frame, I'm going to come back into the frame with a bottle in hand. It will be detecting that as well. You can see that right off the bat. It's able to find that. It's my Kubernetes bottle that I got at the, I think third or fourth Cloud Native Compute Foundation conference. It also identified there, no text visible. Now I'm going to come back into frame with a box in hand. I've printed out a fake UPS label, and it was already able to read off that UPS label the address and information, and I'll also provide a description for that as well. Finally, I'm going to come back into frame with a placard that has a alert signal on it saying something is a caution or danger. And what we should see here is that the Gemma model has identified this as being an alert situation, and we need to make sure to take extra caution when we are interacting. And that's it. As I mentioned, all of that is happening on frame, on device itself, which is super powerful because that means that you're able to get much quicker response time to all of these various things rather than always having to go back to a central authority to do inference. So now that you've seen that, the architecture I want to lay out for you is really straightforward. As I said, we have that camera. The camera feeds directly into Expanso Edge. Expanso Edge grabs it and passes it through to that Gemma model running on that local endpoint, which then produces structured outputs. And you can see all the details of what we're operating on here. In fact, we're using the Gemma E2B model, the smallest one they have, but we are able to get phenomenal performance out of this, even on Jetson Orin 8 gigabyte machine, just about $500, and processes very effectively over the data that we're collecting. So going back to the summary, really straightforward stuff. One YAML for analysis right there, on, real time on the edge. Camera goes to model, Expanso Edge then pushes it into structured output. And ultimately, while I have given you a bunch of demos here, I'm going to open source this. We have open sourced this, and you can go download this yourself to play around with. But outside of that, it's really ready for you to go and take advantage of the terrific thing that Google has done by releasing this, and of course, Expanso Edge running on your infrastructure, not on the cloud. Thank you very much.